All right, so the topic today, which will be on your slide, is inverse. So first thing is just a little refresher about function notation. Function notation, remember that the name of the function is the letter out in front, and that's the name of the function. So this is f of x. We've talked about this before. This should be brand new to you. And the variable of the function is inside. So that's f of x. Again, we've talked about that before. You've seen it before. You guys are masters. Master functioneers. Okay? Today, we're talking about the inverse of f of x. So the notation, how we would write it, would be f, or the name, g, h, q, whatever you want, whatever the name of your function is, and then an exponent of -1, and then the variable. So this one gets read the inverse of f of x. That's how we say it. Or the inverse of. So that's what we're going to do. We're going to first find how to figure out how to find inverses. And then we're going to figure out how to prove that two functions are inverses. Okay? 3, 2, 1, go. All right. So I'm going to break it down into 4 quick and easy steps on how to find an inverse. So, but first, we're going to use this function. We're going to use f of x equals 4x plus 2. We're going to use that function as our function. We're going to find the inverse of it.
Do you do this? Do you like follow the script, or is it just like?
What do you mean?
Like you teach?
When I teach? No, I'm off the cuff, man. Yeah.
Well, I mean, it all seems so planned out the way it's like.
Oh, it's all planned out up here.
Right.
Getting it to this point, though, that's this class is different than the first class, then it's different than the next class. You know what I mean?
Yeah. So
It's all the same information. It's all kind of the same, but what I'm saying in between is never the same.
getting an input the same.
Yeah.
Little.
Yeah.
I get there.
Totally different. All right. So to find the inverse, the first thing that we're going to do is we're going to take it out of function notation, and we're going to make an equation. We're going to make it into an equation notation. Okay? So what we're going to do is we're going to take f of x, and we're going to make it be y instead. Okay? So we're going to replace f of x with y. So this is basically going to look like y equals 4x plus 2.
That looks like something familiar.
Now it's back to something that we know, right? Now it's a line. And we're going to find the inverse of that line. Okay? So that's step number 1. We're going to replace y, or replace f of x with y. Okay? Step number 2 says all we got to do now is switch x and y. Okay? So wherever x is, you write y. Wherever y is, you write x. So that looks like x there.
So you leave the 4.
Leave the 4. Y goes there now. And you leave the plus 2. So instead of y equals 4x plus 2, now it's x equals 4y plus 2. All you do is switch the x and y. Okay? That's step number 2. Step number 3 says, now we take this new equation and we solve it for y. Okay? Okay? So how would I solve x equals 4y plus 2 for y? What? Subtract 2. Get y by itself. By first we subtract 2. Okay? We're going to go first minus 2 minus 2. And then that's going to become x minus 2 equals 4y. And then divide everything by 4. Right? So then that's going to become x minus 2 over 4. Or can I simplify that even more? What can I simplify it to?
X minus 1 divided by 2.
Do we all agree that that would become x minus 1 divided by 2?
No.
Like, what do you mean simplify the x part? By 4. Or simplify, divide everything. Simplify. Right. So can I go any further than this? No. Can't go any further than this. Alright? So that's step 3. And we're okay with that. The last step, because we read that was going to be a 4-step process. The last step is, now that we've done that, now we can take y away and put it back into function notation. But now instead of putting f of x in there, because it's not f of x, it's the inverse of f. So we would write f with a negative 1 exponent of x equals x minus 2 all divided by 4. Okay? Questions on that? That is the entire process of finding an inverse. So if I asked you to find an inverse, you would first start with your function. Make it become y equals, and put it in the equation. Switch the x and y. Solve for y. That's it. It's a
If you wanted to, we start writing some terms.
all right. Here we go. Which of these is the inverse of that one? Well, let's find the inverse. First off, what I'm going to do, I'm going to move these up just a little bit. Give me a little more workspace here, you know what I'm saying? Okay, so I've got f of x equals 3x to the 5th minus 2. Step number 1 says I do what?
Put the y in.
For what?
For f.
For f of x. So that means it becomes y equals 3x to the 5th minus 2. Okay? Step number 2.
Switch positions of the x and the y.
So switch x and y, right? So it would become what?
X equals 3y to x2.
Now what?
So,
Okay, how? Add 2. I like the add 2 part.
and then
I don't know what you call it, but do the root thingy.
The root thingy?
Yeah.
that's the-
Fifth root thingy? Right here, right now?
well, it'll be- you get divided by
What do you got,
three.
Skokie? We're going to divide by 3 first. Yeah. Yeah, we're going to divide by 3 first.
And now we're going to fit through.
Now we're going to fifth root. Okay?
So f of x equals
So the inverse, right? Not f of x.
f of x 1x.
So the inverse of f would be the 5th root of x plus 2, which is, so I know it's not the middle one, the middle 2, right? Last one you're going with? Okay. What's the difference between the last one and the first one? What you got, Paige? It's doing the whole thing. Last one's doing the whole thing. First one's only just doing the numerator. Yeah. Yeah. So that's this one. Right there. Love it. Love it.
Very.
Okay? Alright, so now here's the kicker. That one right there. Okay? So the composition property of inverses. So if f of x and g of x are inverses, okay, then this statement has to be true. If they are truly inverses, this red statement here, f of g of x is x, and g of f of x is x. I'll give you a second to write that down because it's uber important. So what that means is that we have to show both. If I say prove that these functions are inverses, or if I say verify that these functions are inverses of each other, or if I say make sure that these functions are inverses of each other, any of those, you got to show me both of these. You can't show just one. You got to show both. Okay? So what that means is you're going to take g of x, that function, and you're going to put it into f of x anywhere that there's an x. And when you simplify it, it should simplify down to just x. Then you got to take f of x, put it into g of x, and when it simplifies down, it should just be x. Everything should cancel out. Okay? Because what you're doing is you're taking an input, x, you're putting it into the function, the first function. Then you're putting it in that resulting inverse function, which should wash everything off and leave you with just what you put in. You think about it as numbers. If I put 7 into the first function, take that result, put it into the second function. When it comes back out, I should have 7. Right? We can't do just one. We gotta do them both. Okay? Now, these are the two functions that we just made. Or this is the function that we had, and then we found the inverse of it from the first example. With me? Okay? Right? So now, but now it says, I would like you to verify that the functions are truly inverses. So we got to prove that they are inverses. So the first thing that we need to show is we need to show that f of g of x is x. So what I'm going to do is I'm going to take g of x here, and I'm going to put it in for x in f of x. Okay? Here we go. So we're basically going to say f of g of x is 4 times 1/4 x minus 1/2. There's g of x, then plus 2. I took g and I put it in for x in f. With me? Now let's do some math. 4 times 1/4 is 1 times x is x. 4 times 1/2. Half of 4. 2. Then that's minus 2. Then I got this plus 2 sitting out there. x minus 2 plus 2. X. That's what we need it to be, right? Okay? So I just showed that f of g of x is x. Okay? Now, that's not enough. That's only half of the work that needs to be shown. Now I got to show it the other way. So now I got to take f of x and I got to put it in g of x. All right, so I've got to show g of f of x is also x. So g of f of x is 1/4 times 4x plus 2 and minus 1/2. Again, got to do some math. 1/4 times 4. 1 times x. X. 1/4 times 2. 1/2, right? So it's plus 1/2. Yeah. And then I got this minus 1/2. X plus 1/2 minus 1/2. Just that. So since now I've showed both of them, now that I've shown both of them, now I can say with the backing of math behind me, they are inverses. We just proved that they are inverses. Questions, comments, concerns, clarifications? Super funny. All right, here we go. Oh, sure.
10 more seconds.
Sure. Oops, come on now. There we go. All right, so you tell me, are these functions inverses or not? Yeah.
No.
Okay.
Because it would have to be negative 1/3. Because right now they're both still going up.
Okay.
Negative 1/3 would be the opposite of 3. So they would be perpendicular.
Okay. All right. But that works linear ways, yes. But like if we had like the second one where it's the fifth, it's the fifth power, then that logic kind of falls through a little. Okay. All right. You don't think so? Okay. So we've got a couple of different ways that we can answer this question. One way is we could find the inverse of one of them. Change f of x to y, switch x and y, solve for y. If we get the other one, they're inverses. Okay? The other way is we could do the f of g of x and it equals x. Know what I mean? Okay? And then we could do, and if that one works out, then we got to do g of f of x. Make sure that one equals x. Okay? So either way works. Okay? So let's do the f of g of x method. Got to equal x. Okay? So then this is f of g of x would be 3 times something minus 1. And that something's got to be x plus 1. 1/3 times 3. 1 times x. X. 3 times 1. 3. 3 minus 1. 2. This gives me x plus 2. No, right? Hard no, because it's not just x. If one fails, they're not inverses. If this would have passed, we would have had to show g of f of x.
So these are the real fun.
Yes.
If it's linear, do we have to show what?
Yes. You would have to show f of g of x equals x and g of f of x equals x. Yep, I know. Mean old math teacher. I know. Evil. Pure evilness. Alright. So, on this particular one, what I would like you to do is first, I would like you to find the inverse. Doing that whole switch the x and the y, all that fun stuff. Yep. Okay. Then prove that what you got is the inverse by doing the f of g of x, g of f of x. Both of them. So walk me through steps now. First step in finding is what?
You substitute the y in for f of x.
So this becomes y equals x cubed plus 1. Then what?
Then you
Switch my x and the y, right? So x and y get switched. Then I solve for y. So I'm going to subtract 1.
then cube root it.
And then I'm going to cube root it. Oops, I'm going to put cube root of y. Right? Okay? So that's my potential, or what I found, as my inverse of x.
And see, this is where I get confused. Because
All right.
what is the g of x?
Okay? So now, so g of x is my inverse. With me? Second function. Okay? So now, really, I need to figure out that f of the inverse of x is x. Right? So I'm going to take my inverse function, and I'm going to put it in my function. So then that would become,
F of x equals x.
so it would be x cubed plus 1, right? Well, my x is now the cube root of x minus 1. Right?
So it just cancels itself out.
So the cube cancels out the cube root, correct?
Yeah.
So that gives me x minus 1 plus 1
equals x.
is x. That's what I needed. Okay? Then I got to show the inverse of the function also has to be x.
So cube root
So now it's cube root
with x cubed.
right? And then inside now would go x cubed
Plus 1
plus 1.
minus 1.
So x cubed plus 1 minus 1 is
Just
x cubed, right? And what's the cube root of x cubed? So this is truly my inverse.